So first and foremost, for every single word problem, if you have to draw the picture, what is your picture? Okay, so let's start there. So we have a right triangle. If you start there, we can start filling in the information. Okay, so Brian's kite is flying above the field at the end of a 65-meter string. Okay, so where is my kite going to be? This top corner, right? So here's my kite. Now, has anyone flown a kite before? No. Yeah? No. Okay, when you're flying a kite, are you standing like this and your kite's straight, like up and down vertically, or is that at the angle? It's at the angle. So this is my string that is 65 meters. When you hold a kite, you technically have to run with it, but the string is at an angle. Okay? If the angle of elevation, so if you were standing down here, so this is you down here, holding the string, the angle of elevation is 70 degrees. And Brian is holding the kite 1.2 meters off the ground. Now this is the tricky part. What does that actually mean? What's 1.2 meters off the ground? How high his hand is. Because when you're flying a kite, for those of you that have never flown a kite, you don't get to lay on the ground and like hope your kite stays in the air, right? You have to hold it, and typically you run to give it some like oomph, and you're holding on to it. So the distance that he is holding the kite is 1.2 meters off the ground. Okay, so we're not on the ground. This one was probably the most tricky, and of course it's number 1, right? Okay, so how high above the ground is the kite? So we want to know this entire distance, but our ground really starts down here. So if I find x, I know this part is 1.2, and I can add them together. Okay, so what sides do I have? I have the hypotenuse and the opposite. The 1.2 is not a part of your triangle. Okay? So the 1.2 is not a part of your triangle. So opposite and hypotenuse is sine. The sine of 70 equals the opposite, whoops, that should be a 65, over the hypotenuse. And what do I do with that problem? Multiply. So 65 times the sine of 70 gives you 61.1. And that's meters. Okay, so the distance from the kite to technically where Brian's hand is 61.1 meters, but the distance from his hand to the ground is another 1.2 meters. So we're going to add that 1.2. So the entire distance of the kite is 62.3 meters. Do you see that? Does that make sense? A little bit? So this is actually super important because next week we're going to be measuring the heights of things on campus. And in order to measure, you're going to be holding your phone, but you're going to measure the angle of elevation from your eyesight. So you need to know how tall you are from your eyeballs to the ground. And that part's going to be incorporated into solving the height of the library. Okay? We'll get there. We'll talk about all that next week. From head to toe, you're 5'4". Well, your eyes are not at 5'4". Okay. Shh. Let's go on to number 2. So, did anybody get number 1 right? One person? A couple people? Okay. All the avid people? Because someone helped you with it? Okay. So, problem 2. Okay, from an airplane. From an airplane at an altitude or a height of 1,200 meters. Okay, so the airplane's in the air. So here's where my airplane is. And it's 1,200 meters above the ground. Right? The angle of depression. Remember, the angle of depression is outside of the triangle, and it's looking at a rock. The angle of depression is 28 degrees. Find the distance from the plane to the rock. Here's the plane, here's the rock, here's the distance I'm looking for. What do we know about the angle of depression? It's congruent to the angle of elevation, which is going to be here. Because now I have enough information inside my triangle. I have the opposite and the hypotenuse again. So sine. The sine of 28 equals the opposite over the hypotenuse. What type of problem is this? It's a division. It's a flip and divide. X equals 1,200 divided by the sine of 28. And we get 2,556.1 meters. Did we get that? Was that one easier for those of you that did it than the first one? Okay. Let's look at the last one. Okay, from the point on the ground, 12 feet from the base of a flagpole. So here's my flagpole. And we have a point on the ground that's 12 feet from the base. So here's the base of the flagpole. This part here is 12 feet away. So the point on the ground, here's my point on the ground, 12 feet from the flagpole. The angle of elevation to the top of the pole measures 53 degrees. How tall is the flagpole? This one hopefully was really straightforward. Okay, I have the opposite and the adjacent, which is, which trig function? So the tangent of 53 degrees equals the opposite over the adjacent. This is a multiplication problem. So 12 times the tangent of 53 should give you 15.9 feet.